talk a little bit about what's in a patent application. As I said in a subsequent lecture, we'll just take an actual patent application and we'll quickly go through the different parts. But for now, let's just do a quick overview, just a couple slides on what's in there. And of course, it looks a little bit like a paper, a scientific paper. You have a background describing the state of the art. So this gives context. You do want to reference other patents that are relevant, but it's not quite like a scientific publication where you reference a lot of non-patent literature. I mean, you can do that, but most attorneys I've worked with, that's not that useful. So for example, if you use a scientific paper as a basis for a patent, they'll probably rip out most of that. I mean, if there's a good review paper to give the examiner background, that might stay in there. But what's more relevant is they're really looking for the patent background in addition to the context supplied by you in words. Then move into what in a scientific paper would be the body of the presentation of the paper. And inside a patent, the really important thing is that you have to be able to teach someone, again, an average person of skill in the art, which means that if it requires too much special knowledge and special interpretation of your words in the patent, then actually that's not good, because later on in principle, someone could say, look, unless you are someone with really unique knowledge, this is not really full disclosure here, and therefore it's an invalid patent. So you want to make sure that in the technical description that you can actually do what you say you're going to do, and that there's enough description in there to teach someone, average person skilled in the art. Remember the original example I gave about the king giving the artisan a monopoly to only produce that for the kingdom for some period of time, as long as that artisan talks about how he was able to make such finery, right? And that allowed other people then to learn and then not produce just that, because it's just copying that's already protected, but they could take that and make more advanced things. So this is the whole idea that disclosure is going to accelerate development. So that's the patent bargain, and that's why the teaching part's important. If you try to hide or not put much into the body, then it will be under attack later if it becomes an important patent. So in general, after you do all this description and everything else, this is the real important part of the patent. Like if you look at what lawyers or people that are trying to use patents, let's say strategically, nobody really reads the body that much or the background unless there's some finer points you're trying to find in there. Usually you go right to the back and look at the claims, because the body can give lots and lots of descriptions about all sorts of things. But the truth is there might be prior art which covers 90% of it, and so they can only get this little extra improvement, which means that the claims would have to be very, very, very specific. So if there's a crowded area where there's been a lot of previous patents, then you'd have to make a very, very, very specific description, and that limits, of course, how much area you can cover in sort of patent space, right? The real way you see this is this property deed analogy. So let me do some drawings here where so let's suppose that there's some new field represented by this box, which is in the property deed analogy, all the land that's available. Okay, and in that field, which you can think of literally as a grass field, right? But in the field, even a technical field, my invention, let's say, is the first one to really land on this fresh area. So for example, strained silicon was kind of like that, because you say, well, wait a minute, that was silicon. But see, once there's something as novel as strained silicon, you can use strained silicon to build so many things. And actually, because strained silicon is unique, it changes their properties. It's kind of a whole new easy phase space, right? So something like that, that's very fundamental shift, big idea that gets done, you should have the ability to actually write a patent that has very broad claims. So this type of thing, if we think of property analogy, would be broad claims, because there's not much out there, and it allows you to claim, this much. So even though your example may have been a very specific version of this, for example, in our case, we demonstrated this using germanium silicon all the way under the channel, okay? And in future embodiments, people didn't, but because we were first, and we knew exactly that there would be other versions and everything else, we could patent things like strained silicon inverter, let's say, where it's quite general. And even though, we only demonstrated this little piece of it, the discovery is big enough and broad enough that we could actually claim quite a larger area. So then if somebody comes in later, like Intel did, and says, well, I changed this a little bit over here, well, the truth is it's still covered, right? Now, you can actually do the opposite strategy. Let's suppose this is the field, and you're not really actively working in it, but it worries you, because if someone were to figure it out, it would cause a mess. And so you have one very specific thing, but again, because you can't quite understand what the big advance would be, you actually just put little specific things. You haven't gotten the big idea yet, but in this field, you pepper this place with these little inventions. Now, if someone actually does come along, and they say, oh my goodness, I figured it out, and they try to make a broad claim like this, they can't, because these things are in the way. So essentially, you force the language and the claims to actually be forced into a space like this. Okay? So you forced the actual novel innovator who really understands the whole thing eventually, because they were second and they weren't first in at least recognizing this field, you're able to squeeze them in. Big corporations do this a lot if they don't want to spend a lot of money on basic research, like we talk about, because the probability for them to capture it these days is difficult because of competitive end markets. And so what they'll do is throw out these very specific things that really don't claim too much, but they're existing in that field, and if somebody does come along, it makes it very difficult to claim the whole thing. So this is what's meant. It is meant by, this is the property deed analogy. Anybody that goes to learn about patents in law school, this is the kind of thing. So in general, just completing the analogy then, if there's some field, what you'd like to do is actually have the big advance in it and make really broad claims. And then, as you continue to advance in the field, what you would like to do is pepper it with little ones all over the place. What this strategy does is a couple things. First of all, if anybody attacks your original most broad claims, and they actually win, even if it's not true, because you got to assume that sometimes things don't actually go the way they should, you still have these things there, and you prevent someone else from going in here, and all these areas are still protected. Also, if this area remains, you have these little satellites that really prevent someone even from coming in and doing this, so they can only do this or this or this, so it kind of limits their area. So that's what's meant by a whole patent portfolio. Generally, just because you get the original big patent, it's rarely enough to really protect an area, and so you like to build a whole strategy around, that space. So this is the another reason about the provisional versus non-provisional. If the provisional doesn't have enough information to teach, and you only have a single research result you want to present at a conference, that's when patent lawyers don't like you going there and doing that. On the other hand, that one little idea you still feel like could be a big idea later, you might want to protect it, and so you do the provisional. But the emphasis here is about the teaching part, that you don't want to get into a problem and later that you didn't teach enough in this one, and the things you want to cover, you put these big claims in, but they're actually not covered by the body. This is a problem. Remember before I said that the claims are the most important part and nobody ever reads the body, but I said you could go back for some finer points. Well, one of the finer points is that, let's suppose somebody is claiming something pretty broad, and when you go back and you look, the very specific case is there, but not the case for teaching the broad, and they don't give any other example. You know, that's could be a problem. A bigger problem is where the specific thing that you're trying to claim is not specifically talked about either under a broad umbrella or a specific umbrella in the body. That's a bigger problem. So you definitely have to, whatever you're claiming, it can't just be a game of claiming space. You better have remembered to describe enough in the body that those claims are covered. So documenting inventions used to be much more important when it was first to invent. And since March 2013, that's disappeared. Since the middle of March 2013, this has become a little bit less important. But, you know, somehow I have this feeling that, you know, it's still relevant for different reasons. And so I think that that even though this is not the case anymore, I'm going to make sure that, just in case nobody's listening to my voice here, this is no longer true after, I think it was March 15th, 2013. So that's not the case anymore. Even in this day, of course, documentation does not equal prior art. And it is about notebook to show that you can't generate afterwards, and all these things were necessary to show that you invented it. Of course, now what this means is that you want to have that first filing done as soon as possible, and you still probably want to keep nice notebooks, because if you want to file fast, you'd probably just like to take it in some really organized way and get it right out to the patent office fast. And so you probably still want to follow those instructions. So this is kind of an interesting thing, because people who write scientific papers tend to want to put the same people that are involved in the scientific paper on the patent. And here's the problem with that. It's actually a legalistic determination. It doesn't fit the social aspects of scientific publication. So generally, in a scientific publication, you generally try to put anybody that's contributed to the paper on there, even if they just carried a sample, so to speak, right? And that's because you don't want to offend anybody, and you know, some folks don't get a chance to be first author because they're support personnel, and you want to help them out. But the tough thing is leaving them off patents, and it's important to do so. And the reason is that they have to have contributed an essential part of a claim. So most people don't realize this, but if there's an inventor on a patent and that inventor really didn't contribute, you could, in principle, if you could prove that that person, you know, really didn't do that much, you could invalidate the patent. Now, I don't know of any case of it happening, so I think it's pretty tough. But as someone who's writing patents, you should realize that you know, you really should only put people on there that have directly contributed to the invention itself. So we've talked a little bit about IP strategies. There's plenty more, and I'm going to talk about the Amberwave example in a following lecture. But you know, in this case, talked about using the U.S. As a way to deal with the affordability issue, because if I can't afford to patent all these countries because $100,000 per patent over the lifetime of the patent, is a little steep, or the upfront expenses are a little steep for all those, then U.S. is a huge market. It's got a good protection. It's easier to enforce than, say, in China. Then what you would do is get in the U.S., and then anytime the invention comes across the border, you can stop it if the person outside isn't giving you a license or has permission to use your. That's an example of, you just can't patent everywhere necessarily, that there has to be a business thought that as you're innovating and as you go through this iterative innovation process, you have to take into account the amount of profit and cash and fundraising and everything else available, because you might not be able to do all the patents and you have to come to some compromise. So this is an important thing, which is that you have to have a business objective. And in the Ambroyev case, it was first protection in case. Then after circumstances arrived, it became the business model. So there's an example of business objective that changed. And IP was important for both cases. In the first case, protection in case of rainy day, and then when the rainy day happened, the actual only thing that the company could contribute to was the business model of an IP company. And so therefore you have to think about the competitors, the customers, and decide where they are and how to lay out your strategy. So if you think about it from a offensive use, you can use it to prevent your competitors from doing what you're doing. So for example, I make the latest generation of some product, and it's got some new gee whiz bang technology that's really hard to do. If I have a patent, I can actually hold them off from using that for 20 years. Now, usually there's improvements and things like that. And so what happens if they set out to do the improvements and they do those before you, and then you need those improvements, but you got the original, then you'll just cross-license at the end of the day. So what you see is that even though you have an advantage and you're walling out competitors, it's actually very difficult to wall them out for 20 years or something like that. So usually it kind of goes through an evolution where, the really innovative firm, if they happen to get good IP, they wall out their competitors. Competitors have to enter space. The customers want them to enter because, it makes more competition, lowers price. So there's tremendous pressure over time for everybody to contribute. And then once everybody does start contributing to the area, there's lots of cross-licensing. And then, you're kind of at equilibrium where nobody's suing anybody anymore. The licensing model is nice. I explained in previous lectures, though, that you cannot really ever sit out and just have patents. You need to be in some other model first. Like in the Ambroyev case, they were doing engineering services and materials at smaller volume, and while it was penetrating more slowly, that was a perfectly fine model for a small company. The minute that big company really embraces it, all of a sudden it forces them to become an IP company. But if you think about it, all that effort before that time in the other business model made it penetrate far enough that it forced competitors to jump in and do that technology. So, just kind of starting off as a licensing company is very difficult. You're going to have to help that technology get in there, and really, whether you become a licensing company or not depends on the evolution of that field. If circumstances don't change, you could just stay in there as a materials or service company or something like that, and you have IP to protect you and wall out competitors, like the first bullet right here. Talked about in certain countries, policing the patent could be difficult. And the other thing is, you have to be ready to litigate in order to wall out competitors or get licensing. And this is, in the Ambroyev case, I didn't talk about this, but they actually raised capital to do just that, to prove that they were going to defend and protect their IP. So sometimes it's not so easy to raise capital just for a lawsuit. Defensive strategies are that you could have a patent and you just want to practice that. You're not out there to stop anybody else, but you just want to keep yourself free to operate. So this is kind of the other side of the first bullet point. Instead of walling out competitors who are trying to compete with you, all you're attempting to do is you'd like to just prevent other people from interfering with you. I mentioned the cross license. Suppose that somebody's got a huge advance, they're cranking along. I try to make an advanced version of it that they'll need so that then I can trade them for the original, and that way we're both cross-licensed and now even again. So it's kind of like the mutual assured destruction. If they've got a weapon, I got to get another weapon, and then we kind of counterbalance each other. If you're going to use a defensive thing, one of the interesting strategies is, well, instead of just using a patent only to protect yourself, remember about how you couldn't reveal it to the public in the first place because then it becomes public domain and nobody can own it because the public owns it. So a possible lower cost solution would be to actually publish it in a journal, and then no one else can patent it because it's public domain. Now, you can't use it offensively against anyone else, but at least no one can use that against you. You're free to operate. So IP has value. IP, like when Amberwave started, the exclusive license of IP, of intellectual property going into a little startup makes investors realize that, hey, this is what they have. I can read the claims, and yes, I believe that those are going to be important things. So it's better than if I have choice of two companies. This one's got the patents, this one does not. I think I'll go with the ones with the patents. So there is some incremental value there that is hard to quantify, but it's definitely a value. Of course, in acquisition, same thing. In fact, if those patents mean more with time because of what you did with your company, of course, the value is higher. And you could possibly use them as collateral in a variety of ways. And all the things we mentioned before. So suppose that we'd like to do a JV. I've got some technology, you've got some technology. Put the technology together, we can create a new thing. So we create a new entity called a joint venture. We each put capital in, we each put technology in, or some combination of the above. So IP is kind of a useful thing as long as it's around something that people are going to care about. When you've patented things people care about, there's a lot of uses for them. So I'll end here with a Steve Frank had come into our class for many years and talked to us about these things. And so he had written a book to try to help managers and investors and folks dealing with intellectual property. So this is just a little advertisement saying that if you're interested in more of these topics, this is one resource for you to read.